The second reducing agent that we have to study is lithium aluminium hydride. Lithium aluminium hydride is prepared by slowly adding anhydrous aluminium chloride to a very thin paste of lithium hydride. So, to a paste of lithium hydride, aluminium chloride is gradually added, and this is taken in the solvent ether to form lithium aluminium hydride plus lithium chloride. Lithium chloride precipitates out and it is removed by filtration, and the filtrate will have our solvent and our lithium aluminium hydride. So the solvent removal is carried out in the absence of air and carbon dioxide to get the lithium aluminium hydride, which is our reducing reagent. Okay, so this lithium aluminium hydride will be present in the filtrate. Filtrate will have this plus solvent. So solvent is evaporated. This filtrate is evaporated in absence of air and CO2 to obtain solid lithium aluminium hydride reagent. Aluminium chloride was added gradually. And this was the thin paste of lithium aluminium hydride. So preparation is gradual addition of lithium chloride in thin paste of lithium hydride in ether to obtain a precipitation of lithium chloride and a filtrate having lithium aluminium hydride, which is separated by evaporating the filtrate in the absence of air and CO2 to obtain the solid reagent. Okay, if we talk about the properties, so it's a gray white solid. Lithium aluminium hydride is gray white solid. It can be very easily hydrolyzed by water, and on hydrolysis it produces hydrogen gas. It's inflammable, spontaneously inflammable powder. This hydrolysis by water is a violent reaction. It's a very aggressive reaction, and even it gets burnt spontaneously when exposed to air. So the storage and its use in the lab require various precautions. We talk about uses. Again, it's a reducing agent, so it is used in the reduction of aldehyde, ketone. Aldehyde and ketones were also reduced by NaBH4, but along with aldehyde and ketone, lithium aluminium hydride can reduce esters, amides, nitriles, azide, etc. So, like we have discussed in the case of sodium borohydride, that lithium aluminium hydride is a stronger reducing agent as compared to your sodium borohydride. Sodium borohydride could only reduce aldehyde and ketone and acid chloride, but lithium aluminium hydride can also reduce ester, amide, nitrile, azides, etc. There is no effect on the double bonds or triple bonds. Alkene and alkyne functional groups are not sensitive to lithium aluminium hydride. Okay. And 1 mole of lithium aluminium hydride provides 4 equivalent of hydrogen. So if we are reducing a carbonyl group and it get reduced to alcoholic functional group, then 1 mole of lithium aluminium hydride could reduce 4 moles of the carbonyl functional group. While on the other hand, if we have ester group, then 1 mole can reduce 2 moles of ester. If we discuss the reactions, the very first is reduction of carbonyl compound. Carbonyl compounds means aldehyde or ketone. Reduction of aldehyde or ketone. Aldehyde and ketones are converted to alcohols. Aldehyde will give us primary alcohol while ketones will give us secondary alcohol. Aldehydes are not aldehydes and ketones are not directly reduced to alcohols, but first aluminium alkoxide is formed, which when treated with aqueous acid gives us the alcohol. So reaction goes this way. Let's say we have a ketone. This ketone on reaction with lithium aluminium hydride gives us the aluminium alkoxide. Aluminium, lithium positive. So if we balance it, so this is aluminium alkoxide which is first formed. This is treated with aqueous acid solution to get aldehyde alcohol CH2OH. So this will be the alcohol obtained plus lithium hydroxide plus aluminium hydroxide. Aluminium hydroxide will precipitate and you will get 4 moles of alcohol. This is a secondary alcohol since we were taking ketone. Ketone give us secondary alcohol. Also, there were 4 equivalents of ketone while only 1 equivalence of lithium aluminium hydride. So the statement that I just said before these reactions, that 1 mole of lithium aluminium hydride could reduce 4 moles of carbonyl compound. Okay. Now looking at some of the reactions, this is hexanal. When treated with lithium aluminium hydride, the aldehyde group will be converted into alcohol. So in case of aldehyde, what we are getting is primary alcohol. In second reaction, we have a ketonic group when treated with lithium aluminum hydride. Sorry, this secondary alcohol will be obtained. This is butane 2-ol. Third reaction is proton aldehyde. Proton aldehyde have a conjugated double bond present with aldehyde group. But since we have discussed earlier, the aldehyde ketonic aldehyde ester group amides, these will be reduced by lithium aluminum hydride, but there will be no effect on the double bond present. So the product in this case will be CH3 CH double bond CH CH2OH. So this is crotyl alcohol. Next is cinnamic aldehyde. In cinnamic aldehyde also we have similar kind of conjugated double bond present along with aldehyde, but there is further conjugation to the benzene ring, and there is a slightly different reaction shown by cinnamic aldehyde with lithium aluminum hydride. In case of cinnamic aldehyde, we are getting a different reaction. So in this case, the double bond also get reduced, and the product obtained is benzyl ethyl alcohol. No, it's benzyl propyl alcohol. So this is the product obtained. Next is acids and acid derivatives. Acids and acid derivatives except amides are reduced to alcohol by lithium aluminum hydride. So all of these acids and acid derivatives give alcohol reduced to alcohols. So majorly carbonyl compound, acids and all the acid derivatives except amides gives us alcohol as a product. If you look at the reaction, this is an acid group, it is getting converted into alcohol, that means CH2OH. If we talk about acid chloride, again acid chloride will give us CH3CH2OH. Ester on treatment with lithium aluminum hydride gives us two products, CH3CH2OH plus CH3OH. Two products, two alcohols are obtained in this case. Now third is amides, the one that we have left here as exception. Amides are converted to or reduced to amines. So if you have RCONH2 on treatment with lithium aluminium hydride, RCH2NH2 is obtained. Or if you have substituted amide, even then similar kind of reaction will be shown and the product will be RCH2NHCH3. So this way amides are converted into amines. Now nitro groups. Nitro groups, if aliphatic nitro groups are present, then those are converted into amines. But if aromatic nitro groups are present, then azo products are obtained. Let's see an example. Let's say R1NO2 on reduction with lithium aluminium hydride in presence of THF gives us R1NH2. While if you have nitrobenzene, first on treating with lithium aluminium hydride in ether, and secondly treating with aqueous acid, azobenzene is obtained as a product. If we talk about azides, azides are also reduced by lithium aluminium hydride to give amines. So one was amide which was forming amines and another is azide. So RNH3 on reaction with lithium aluminium hydride gives us RNH2. If we look at there are various reactions which are carried out by using lithium aluminium hydride. If we talk about sulfonyl chloride, sulfonyl chloride gives us thiol. So the structure is something like this. Sulfonyl chloride. Sulfonyl chloride forms thiol. Similarly, sulfoxide, R2SO, sulfoxide. This on treatment with lithium aluminium hydride gives us thioether. Or you can write R2S. This is thioether. Sulfones. Sulfones also give thioether as product. Halides, these are sulfones. Sulfone also from thioether. If we talk about halides, halides get reduced to hydrocarbon. Sulfonyl chloride, sulfones, sulfoxides, halides. Halides form hydrocarbon. Let's take a journal halide, alkyl chloride in presence of lithium aluminium hydride gives us hydrocarbon, lithium chloride plus aluminum chloride. So these are some reactions which are carried out by using lithium aluminium hydride as a reducing agent.